Hi guys, welcome back to Flip Geometry. It's video number 5. And we're on to our final shape here in this series. We're looking at the trapezoid, and specifically what we're going to do is to look at how you calculate the area of the trapezoid and why you calculate it that way. So a trapezoid by definition is a quadrilateral. It has those 4 sides. 2 of those sides are parallel, and I indicated that with the little parallel arrows there. The other 2 sides are angled inward. Now, those 2 sides could be of different lengths at different angles, but they're connecting between the 2 parallel lines. So what that does is that creates one side of the parallels that is shorter than the other. So what I've said is that the top side, let's say, is 4 meters long, and the bottom side is 6 meters long. Now, the distance between the 2, in terms of the perpendicular distance between the 2, the 90-degree angle distance between the 2, we've got listed as 2 meters. And I'm showing that by the red dashed line because, of course, these are angled, so they're not perfectly square to those 2 parallel lines. So, how do we get the area of something like this? Some of you might recognize that I've got 2 triangles and 1 rectangle. Well, that could be a way of doing this. It could be a way by simply chopping it up and determining the areas of each of those things individually. The problem is, we know the area of the rectangle because we know that this is 4 meters and that's 2 meters, so we could get that interior rectangle. The problem comes with the triangles. We know that the distance from there to there is 4 meters, but we're not sure about these other 2 distances. So we don't have enough information to get the base of the triangle. So what do? Well, we have to look at this a little bit of a different way. And to make sense of this, what I'm going to show you is a better way to think about dealing with the area of a trapezoid. So bear with me for just a second. I'm going to draw another trapezoid here. So I'm simply going to redraw our trapezoid like this. Okay, pretty close, more or less. And we know that at the top here, we've got 4 meters here, and we've got 6 meters here. What I'm going to do is I'm going to take this trapezoid and I'm going to flip it over. Okay? So I'm taking this and flipping it over, and I'm going to move it so it's right beside here. Maybe what I'll do is I'll draw it in blue just so you can see that. So when I flip it over, what's going to happen is it's going to match up perfectly here, and, well, I drew that one slightly bigger, but the idea being if I perfectly flip that, it would fit right there. Here, I can chop it down just a little bit so it's better. There you go, a little bit better. So what's happened with our numbers? Well, this 4 has flipped, so now it's down here. So we've got 6 meters here, 4 meters here. This is 4 meters, that has flipped, so we now have the 6 meters on that side. Well, some of you are probably sitting there saying, well, now I see it. Now what you've created is this shape. From here, all the way to here, up, all the way across, and then down. You might recognize that green shape because it's sitting right there. What we've created by flipping that and adding that trapezoid there is one big parallelogram. So that big parallelogram now, we know the formula. It's simply the base multiplied by its height. Well, if we think about that for a second, the base and the height of this parallelogram, let's indicate that in green because that's the area we're dealing with. The area of that is simply the entire base, which would be there to there, right? So there to there. That's 6 plus the 4. So what I'm going to do is show it that way. 6 plus the 4. Then what we would have to do is multiply it by the height. Now back here I told you that it was 2 meters here. 2 meters. If we flip that over, it's still going to be 2 meters. Nothing has changed. We're still at a 2-meter height there. So what you've got is 6 plus 4, that's your base area, multiplied by our h, which is the 2. So we've got 6 plus 4 multiplied by 2. In the end here, of course, we have 10 multiplied by 2, which gives us 20 meters squared. So the area of that full parallelogram in green is the area of that full parallelogram. But of course, we only want the area of the trapezoid. We only want the area inside this one shape right here. We're just looking for that trapezoid area. What are we going to do? Well, that represents exactly half of the parallelogram. So that area being exactly half of the parallelogram, well, it's half of 20, which is 10 meters squared. Let me show you the calculation, though. Here, we started with the idea that the area is equal to the bases. So the sum of the bases, 6 plus 4. Now remember, that's our two bases here. So let's call them base 1 and base 2. So if we've got base 1 and base 2 there, and I'm just going to move this over a little bit so you can actually see it. So if I've got the area, I'll call that A, and I've got base 1 and base 2. So I've got my base 1 and my base 2, my 4 and my 6. I can add those up, which is what I did there. That combination all got multiplied by our height. So there it is there. Now that's what we have down here. Base 1 plus base 2 multiplied by the height. However, for us, we're looking for just the trapezoid, which is exactly half of that parallelogram. Well, if this gives us the parallelogram, half of this is going to give us the trapezoid. So let me just finish that off for us. If we're looking for just the area of a single trapezoid, we take the base 1, which we can say is 6 or 4. It doesn't really matter because 4 plus 6 gives us 10. 6 plus 4 gives us 10. So I'll say it's the bottom one. We have the 6 plus the 4. We multiply it by our h, which is 2. And that whole thing gets divided by 2. So in the end, the area of just the trapezoid now, we have 10 multiplied by 2, all divided by 2. The 2's can cancel. We get the area being 10 meters squared. So the area of 10 meters squared tells us the area of the trapezoid. Exactly half of the area of that parallelogram.